you have to be able to look at the name of the compound or the formula, depending on whichever one they give you. And before you can figure out how to write, its formula or its name, you have to know which type it is. And so, last week it was only covalent, so it was pretty easy because they all had prefixes. They were all two nonmetals, so they all followed that pattern. But now that this week we're going to be introducing our ionic compounds, from now on, you're going to have to figure out which type it is first. Because as you're going to see in the lesson today, ionic compounds do not use prefixes, okay? And the reason for that has to do with the fact that ionic compounds don't have multiple combinations like the covalent. The covalent, because they're sharing electrons, we talked about last week, that we could have like carbon dioxide or carbon monoxide. They both have carbon and oxygen, just different amounts because the bonding is being done a little differently with their sharing of their electrons. With ionics, because they're not sharing, they're transferring electrons, they only will have one way to make the formula, okay? And that has to do with the fact that they have a certain number of electrons that they need to transfer from the metal to the nonmetal. And so there's only one possible combination. And it relates back to when we did our Lewis structures, because if you guys remember, if something only had one valence electron to transfer, then it would have a +1 charge. But if something had needed to gain 2 electrons, then we'd have to add another atom of the +1. So you have to do that kind of balancing, goes back and forth, because the whole point of ionic compounds is that their formulas should equal 0 when you write them. So when we do the lesson on Wednesday for writing their formulas, you'll kind of see that. But for today, just the naming, we need to be able to tell, is it a metal and a nonmetal, or is it 2 nonmetals? Because that's really the key. So this goes back to knowing where your metals and nonmetals are on your periodic table. So if you are still having trouble identifying that, then that might make this a little bit tougher for you to do, because in your little check for understanding quiz today, you have mixed. There are some that are going to be covalent, some that are ionic, and you have to tell me, the name for them correctly. And if you make above a certain grade, then it's going to say like you're done. Okay, you'll be going on to the next thing on Wednesday once it's posted. If you don't make a high enough grade, then it's going to open up another practice assignment that you need to complete, okay? And it's going to kind of walk you through some examples and help you to sort of practice identifying if it's ionic or covalent, does it need prefixes or not? And then on some of the ionics, they have Roman numerals, because some of the transition metals they can be multiple charges. That's the only time that there will be more than one possible combination for ionic compounds, but we still don't use prefixes on them. We use Roman numerals in the name to represent the charge of that transition metal, since we don't know it for sure. So I'm gonna switch over to Canvas really quick and just kind of go through this a little bit. And then I'm actually gonna focus a lot more on the transition metal stuff today in our live call, because that typically is where people have trouble, is figuring out what Roman numeral to put in the name for any of the ones that have transition metals, okay? So kind of to start off, it's just like, hey, do you remember what ions are? Because remember, ionic compounds, they're made up of 2 or more ions, and so a little bit of a recap here on ions. And so we start with our neutral atoms, okay, that we have, and remember, they're either going to lose or gain electrons. So if they do a loss of electrons, remember, they become positively charged, and remember, that's called a cation. That's the positively charged one. If they gain electrons, then they become negatively charged, and that's called the anion, okay? So we need to make sure we know those terms, cation and anion, and which one is positive and which one is negative, because you're going to hear me kind of throughout the rest of the year. I'm going to use those terms cation and anion, and if you don't know what they mean, then you're probably going to be like, what is she talking about? Like, I don't remember, okay? So those are a couple of vocab terms that we need to know. Here's your little recap, so if it helps you to remember, okay? So when you lose an electron or more than one electron, you become a cation, which is positive, and then here's the little like meme over here. It's got the little definition of what's a cation, and it says an ion with positive charge, okay? Because cats have paws, and cations are positively charged. So that's a little like thing to help you remember them. And then the anion, the little trick to remember it is thinking that the word anion, it looks like onion. Okay, they're pronounced differently. Okay, we have onion and anion. Anion sounds like 2 different words put together, anion, okay? But it's spelled like, if we just replace the A with an O, it would look like the word onion. And onions, when you cut them, they usually make you cry, which is typically a negative feeling, okay? So you can think of, cats have paws, they're positively charged, so that's cation. And then onions kind of give you that negative crying feeling. And so we're just replace the O with an A, and that's anion for negative. And then remember that we are not sharing electrons now, we're transferring. So the metal is giving away an electron or electrons, and the non-metal is taking them. And they form those oppositely charged positive and negative ions, okay? And then the oppositely charged ions are attracted to each other. So once they transfer electrons and you have a positive and negative, they're attracted to each other because opposites attract, and that's what forms the bond for an ionic bond. So they're not sharing electrons, they're transferring, and then the opposite charges attract and hold them together. And then we just need to make sure that we remember that metals are the ones that lose, so they form cations. Non-metals typically form anions, and so because of this, anytime we see a compound that has a metal and a non-metal in its formula or in its name, we're going to identify that as an ionic compound because that's going to be making ionic bonds. And so that's really the key here, is you need to look at your name or your formula that they give you and first identify, is it two nonmetals or is it a metal and a nonmetal? Because that's the first step. If you can't even do that, then it's going to be hard for you to tell me the name, because if you can't tell me which type of compound it is, then you don't know which rules to use to name it. And they do have those different rules. All right, so there's a little thing here you can practice and check for understanding. I'm not going to go through that with you guys in class. I'm going to go on to the next part of how do we do the naming, okay? Now, these are called binary ionic compounds. Binary, like bi meaning two. So binary means they're only made of two different elements, okay? On Friday, we're going to get into some that are not binary, some that have more than two elements, and they're kind of a different category, so that's why we're doing them separately. But for today and Wednesday, all of our names and formulas that we do today and Wednesday, they're all going to be binary because that's kind of the basic how we start off. So we're always going to have a metal and a non-metal. And so if you remember when we did the Lewis dot diagrams for them, we started out, we had one atom each, and then we would draw the arrow showing the transfer. And then as long as they each had an octet, then we would draw them with their charges. Remember, the metal got all the 8 dots and it was negatively charged. The non-metal was drawn with no dots because it gave its valence electrons away. And so it got a positive charge, and however many electrons the metal lost, it's a positive that number. So this is +1. And then however many the non-metal gains, it's negative that number. So this one is a +1, -1. But remember, we can have more than one. And so, for example, if I were to put lithium and sulfur together, lithium, again, it's an alkali metal in group 1, so it only has this one valence electron. So it'll give it away to the sulfur, but sulfur, it has 6, so it needs to gain 2. And because it needs to gain 2 to get to that octet of 8, we have to add another lithium atom so that each of the lithium atoms can transfer its valence electron, so that sulfur has that complete octet of 8, okay? And so in cases like this, we have 2 lithiums. They're each a +1 because each of them lost 1 electron. And then the sulfur, because it gained 2 electrons to complete its octet of 8, it has a -2. And so this right here, this tells me that the formula, it's going to be Li2S because I have 2 lithiums and I have 1 sulfur. And so because the charges in ionic compounds always have to balance, that's why there's only ever going to be one combination. Okay, it's not like covalent where we can have multiple combinations. So this Li2S is always going to be that same ionic compound. There's no other way to combine lithium and sulfur because of their charges. Okay. So like I just said, because we can assume the number based on those charges when we did the dot diagrams, we don't need prefixes. So that one we just drew with lithium and sulfur, it's lithium sulfide. If I had magnesium and chlorine put together, that'd be magnesium chloride. If I put potassium and nitrogen together, it's potassium nitride. So the only thing they have in common is you still change the ending on the second element, which is in this case is going to be the non-metal, not the metal. You still change the ending of that second one to IDE, but other than that, they're not the same. You don't use prefixes. Like I didn't say dilithium sulfide. Like if I go back to this picture, I have 2 lithiums, okay? But I did not say dilithium sulfide, okay? Because I don't use prefixes if it's an ionic compound with a metal and non-metal. So this check for understanding question on here, this is checking to make sure, do you know this is an ionic compound, okay? Because some of you guys, you're not going to be paying attention and you're going to go, oh, it's dilithium sulfide because this 2, because you're going to want to put prefixes on everything. So this is what happens when we start combining the 2 different types of names like this. Everybody goes, you guys do 2 things. You do go prefix crazy and you try to put prefixes on every name. And then when we get to the stuff on Friday, we're going to have to actually have parentheses in some of our formulas. And after we do that, some of you guys are going to go parentheses crazy. So don't go prefix crazy today. And then on Friday, don't go parentheses crazy, because that's typically what happens is you guys start trying to put them on everything and they don't all need that. Okay. So this one is just this last one, this lithium sulfide, kind of like it says up here in the example. All right. So there are some metals, the transition metals, and then also a couple of the post-transition metals like tin and lead. So all the ones that are kind of in this middle area, and tin and lead, they can actually form ions with different charges. And that's because they have these weird D block electrons from our electron configurations that kind of are weird and they do different things. And so the only ones in here that don't need Roman numerals are silver, cadmium, and zinc. Okay, silver is always +1 and cadmium and zinc are always +2. But all the other ones in here, they change. They're not like the other columns. So in this column, group 1, all the hydrogen and the alkali metals, because they lose 1 valence electron, they are always +1 when they're an ion charge. In group 2, okay, with beryllium and everything down, the alkaline earth metals, because they lose 2 valence electrons, they will always be +2 on their charge. Okay, so if you can remember the groups and their valence electrons, you should be able to remember their charges. So +1, +2, and then we kind of skip all these transition metals. And then in this column, most things are going to be +3, like aluminum and boron. Okay, although boron's kind of a metalloid, so it does covalent bonding most of the time. But the metals like aluminum and gallium and indium, they're going to be +3. In group 4, the metals will be +4 most of the time. So like silicon, germanium. Tin and lead are +4, but they can also be +2. So that's why they're highlighted this color. And then group 15, because they need to gain 3 electrons to get that octet of 8, they will all be -3. So everything in this column, nitrogen all the way down, they'll be -3. Group 16, they need to gain 2 electrons. So like oxygen and sulfur and selenium, they'll always be -2. And then here my halogens, they only need to gain 1 electron to get that octet. So things like fluorine, chlorine, bromine, and iodine, they're always going to be a -1 charge. And then my noble gases, they don't gain or lose anything, so they're 0. They never have a charge. Okay, so it follows this pattern. It's +1, +2, skip the transition metals, +3. And then this one is kind of variable. It can be + or -4, but a lot of things in here usually will do covalent bonding like carbon and silicon. And then we have -3, -2, -1. Okay, so if you know what group it's in, you should be able to figure out its charge from the periodic table. The only ones you have to do a little work on are these transition metals. Okay, so for those metals, we do Roman numerals and parentheses in the name because, for example, iron can be +2 or +3. So if it's an iron with a +2 charge, we put the Roman numeral 2. If it's an iron with a +3 charge, we use the Roman numeral 3. Okay, and then other elements have multiples as well. Copper can be 1 or 2. Lead can be 2 or 4. And so there are several different ones. So that's why I want to spend a little extra time talking about these Roman numerals and how to calculate them today. Okay, and so you can write the Roman numeral. So I'm going to, actually, I'm going to go back first. So these are a couple of videos that I actually put on the Canvas. I actually just added them. So when you go back to your note page from today, so this page right here, this naming ionic compounds, underneath the lesson, they're at the bottom of the page. So I put these 2 videos, I embedded them here. So if you need to go back and look at them again, if you're trying to do practice with the Roman numerals with the transition metals, that you can go back and refer to them. Okay, but we're going to kind of look at the first one together a little bit here. And so so you can see he's got his periodic table and see how he has labeled above this first group. He has +1, then he has +2, and then over here it's +3, and then he kind of skips this column because a lot of times they can go either way, 4 + or -4. But then here he's got -3, -2, -1. So he's got all these columns labeled with their charges. It's these transition metals here, and then tin and lead. These are the ones that you'll have to do a little work to solve for because we don't know their charge all the time. So I'm going to kind of hit play on this, and then I'm going to pause it every now and then and maybe skip around a little bit because I want you guys to see some examples, and I'm going to go over them with you.
Naming ionic compounds with transition metals. The transition metals are the elements in this part.
Can y'all hear it?
Yes.
Okay, just want to make sure before I go forward.
Part of the periodic table. And when we write the name for an ionic compound that contains transition metals, those names usually have Roman numerals in the middle of them. So in this video, we'll learn how to take the formula for a compound that contains a transition metal and how to write the name for it with Roman numerals and everything. So transition metals. The transition metals are the elements in this part of the periodic table here, and I've written in some of the most common. I'm also going to be talking about some of the metals over here, which aren't technically transition metals, but they act a lot like them. These metals are unique because many of them are able to make multiple ions with different charges. So iron, Fe, for example, is able to make an Fe2+ ion, but it's also able to make an Fe3+ ion. Okay, this is different from the metals, say, over here, that tend to always make ions with the same charge. Sodium, for example, is in this +1 column here. And so when sodium is in an ionic compound, it always makes an ion with a 1+ charge. Magnesium here is in this 2+ column, so when it is in an ionic compound, it makes a 2+ ion. But the transition metals can make a wide variety of different ions with different charges. Some of them can even make 4 or 5 different ions, each with a different charge. So these different charges on transition metals really come into play when we want to name a compound that contains a transition metal. So here we have FeCl3. And for the Fe, the iron, we can't tell right away, just by looking at this, whether the Fe is Fe2+ or whether it's Fe3+, right? We have these two different types of ions that Fe can make. Now, we can distinguish between these two ions by using Roman numerals to give them different names. So the Fe2+ ion, we call that iron 2 with the Roman numeral for 2 in parentheses. The Fe3+ ion, we call that iron 3 with the Roman numeral for 3 in parentheses. And we'll use these ion names when we want to name the whole compound. So if the Fe here turns out to be Fe2+, we'll call this compound iron 2 chloride. And if this iron is iron 3+, we will call the compound iron 3 chloride. So in order to...
So which one do you guys think it might be? You think it's going to be 2 or 3?
Three,
What makes you think it's going to be 3, Uriel?
because a Cl has 3, and I think that'd be the same.
So that's a good thought, but and you are right, it is going to be 3. But what I want to caution you on is don't always rely on that, okay? And the reason is because in this compound Cl, because it's in that next to last column, it's a -1, so that works out. But sometimes, and I'm going to show you guys an example after we finish watching this video, sometimes I can't rely on that. I have to do a little bit of math. So he's going to actually work it out now, showing you the like kind of the math way that you would do it. And then I'm going to do some more examples, and I'm going to show you one where the 3 won't be like, the number won't be as obvious, okay? So yeah, a lot of times you can look at this subscript on your other one and figure it out, but not all the time.
Figure out whether we're talking about iron 2 chloride or iron 3 chloride here. We got to do a little bit of math and work backwards to figure out which of these 2 charges iron has in this particular compound. Let me show you how to do it. So to find the charge of a transition metal, we start by focusing on the ion with a charge that we do know, that's certain, that's not going to change. And for this, that's going to be Cl. Cl is in this column here on the periodic table, so that we know that in an ionic compound, Cl always makes an ion with a 1- charge, okay? So we've got Cl1-. Now, how much total negative charge do we have? We have 3 Cls, so that's going to be 1, 2, 3. And since...
So he wrote out 3 of them because there is that number 3, that subscript right here, because remember that tells me how many of that element are in my compound. So he's written it out 3 separate times just so we can visually see that there's 3 of them and each one of them has a -1 charge or a 1- charge.
So we have 3 of them, the total amount of negative charge is going to be 3 minus.
Okay, so all he did was he added them up. So each one of them was a 1 minus or a -1. So total, there's a -3 or a 3 minus charge for the chlorines that are in that compound.
Now, in an ionic compound, the negative charge always has to balance out with a positive charge. So if we have 3 minus on this side, we've got to have 3 plus on this side.
Okay, does that make sense to everybody? Because remember when we drew the Lewis structures, the charges had to balance because of the transfer of electrons. So what he's saying is if I add up all the negatives for the non-metal, for the chlorine, I get -3 or 3 minus. And so just speaking math-wise, since ionic compounds, the charges have to balance out and be 0. That means that if this is 3 minus, that means the total for the metal, for the iron, has to be a +3. Because if I put those together, that would give me 0. Okay, that's what he's saying right here.
So what's the charge on iron? Well, there is 1 iron ion in this compound, which means that...
So there's only 1 iron because if we look at this formula, there's no subscript, there's no number right behind the iron. So that tells me that there's only 1 iron in the entire compound.
All of the positive charge has to be on this 1 ion, which means that its charge is Fe3+. Okay, so 1 ion of Fe3+ gives us 3+ of charge, which has to be balanced out by the 3 minus over here, which is distributed over the 3 Cl minuses. So that's how we figure out the charge on iron. And since this is iron 3+, the name for this compound is going to be iron 3. And then for Cl, when chlorine becomes a negative ion, we call it chloride. The IDE usually gets added to the name of an element when it becomes a negative ion. So chloride is what we call Cl1-. So iron 3 chloride is the name of this compound. We had to work backwards and figure out the charge of iron, and then we can call it iron.
So, and then the other thing I want to point out, guys, is look at his list of negative ions. You see how he's already changed all their endings to IDE? Okay, because in the name, the non-metal will always be second in an ionic compound. So the negative ion, the non-metal, will always be the second one. So that's the one that it always gets changed to IDE. So last week, if any of you guys were having trouble figuring out how to change the ending of the non-metal to IDE, like where in the name you cut it off, you might want to add this list or some of these into your notes, because we did oxide, but on some of the other examples, it might be a little bit, confusing about where to kind of cut the name off and change it to the IDE. And then these are all of their negative charges because based on the group that they're in. Okay.
3. So if you want to get really good at naming compounds with transition metals and using the Roman numerals and all that, you just got to get a lot of practice. So I've made another video. So
yeah, and I'm going to go ahead and pause it because we're going to do some practice together. But the other video that he's talking about, the one that has the practice, that's the second one that's here on Canvas. So if you want to go back later, if you think like, okay, I need to do more practice because, I'm not totally sure about it, you can kind of watch the rest of that video we just looked at. And then the second one, these are all practice problems with transition metal names. So you can kind of watch him, like see what a formula he gives you. You can pause it, see if you can try to, figure out how to figure out the charge for the Roman numeral, and then you can check yourself. So there's several of them in here. And so that's actually what we are going to do now. I'm going to switch over to my iPad, and we're going to go over a few and see if you guys can tell me what they're going to be. So. Just took it a second to pop up. All right, so you guys should see my blank white screen now. So I'm going to give you guys, I'm going to give y'all a formula. Okay, we'll do the first one together. Okay, I'm going to write a formula, and then we're going to go through and figure out what the charge would be for the Roman numeral for the, because I'm going to give you one that has a transition metal. And then I'm going to let you guys do one on your own. We're going to see if you guys can do it, okay? All right, so the first one I'm going to do is, we're going to do this one together. So I'm going to do, okay, so this is SNO2, okay? So if I'm looking at this formula and I'm asked to write its name, number one, first step, I need to figure out, is this ionic or is it covalent? So I need to look, is it a metal and a nonmetal, or are both of the elements nonmetals? Yeah. So I already told you guys we're doing practice with ionic, okay, but you should always check that first. So SN, okay, if you look on a periodic table, SN is 10, which is a metal, okay, it's in group 14, but it's towards the bottom, so it's still on the left of that stair step line. So that should always be your first thing that you check when you're trying to write a name, is you need to figure out, is it ionic or is it covalent first, so you know the correct way to name it. And if it's ionic, it'll be metal, nonmetal. If it's covalent, it'll be two nonmetals. So that's first step number one. So I know tin is a metal. That tells me this is an ionic compound. That means that I don't use prefixes for the name. So I'm not going to have like dioxide in this name. Okay, I don't need that. But tin is one of those weird metals that he was just talking about. So the metals that will have multiple charges, it's going to be all those, anything in the transition metals. The only exceptions that won't have them in the transition metals, I kind of mentioned earlier, are silver, cadmium, and zinc. Silver is always a +1, and cadmium and zinc are always +2. Those are the only 3 transition metals that don't need Roman numerals. Everything else in the transition metals, and tin and lead, okay, all of those need Roman numerals, okay? So tin is one that needs a Roman numeral, okay? And the reason it needs a Roman numeral is because tin, it can be tin2 or it can be tin4. Now you're gonna see me write the number before the plus sign. The reason I'm doing that is because right now in the beginning, you guys don't know this yet, but eventually if you take more chemistry, you'll find out that the number coming before the sign is the charge. If you write the positive sign or the negative sign before the number, that's actually something called an oxidation state, which is something that you learn about in more advanced chemistry beyond this class. So if I write the number in front of the charge, that's not incorrect, okay? That's just my habit of writing it because I teach some of those other classes. 10 can be a +2 or a +4. So which one do you guys think this is based on the formula? Think it's the 2 or the 4? What do you guys think?
4.
Was that Modi? Was that you? Modi, you think it's the 4?
Yeah.
Okay. What makes you think it's the 4?
Because there's based on the like subscript, there's 2 oxygens that's subtracting like -2. That's right.
Okay. I was just trying to see your reasoning on that. So let's work through the. Say it again. Sorry.
Yes, it needs to be canceled, the G2.
Yeah, so it has to be canceled. So this is one where some people might automatically think this is going to be the 2, because some people will just look at this and they'll go, oh, there's 2 oxygens. That must mean that the 10 is going to be +2. Kind of like, that's kind of like what you did, Ariel, on the one on the video. You said, well, there's a 3 down there, so it's a 3. So on that one, you could assume that one. On this one, you can't, and I'm about to show you why, because you have to work. You have to work through the math like he showed us on the video. So I need to look up oxygen on my periodic table and find what group it's in so that I know oxygen's charge. And if you look on your periodic table, oxygen, remember it's in group 16, which means that it has 6 valence electrons, right? Which means that it needs to gain 2, right, to get to that octet of 8. And if it gains 2, that means that it has a -2 charge. Okay, so everything in group 16. So if you have a periodic table that you printed out to use, then you can label number -2 at the top of group 16. Okay, In fact, that's usually what we do in class. Usually you guys have a periodic table that you've labeled and colored earlier in the year, and then when we get to this point, I usually have you guys add the charges at the top of each column so that it's easier for you to refer to when you look at it. So anything in group 16 is always going to have a -2 charge, and that's because everything in group 16 needs to gain 2 valence electrons to get that octet of 8, because they have 6 and they need to get to 8. So that means that this oxygen, okay, there's 2 of them, right? Because of this subscript that tells me there's 2 oxygens, and each one of them has a -2 charge. So what's the total negative charge in here?
Four.
Yeah, I got 4 minus, or -4. So again, this comes from number 1, looking at this subscript. That subscript tells me that I have to have 2 oxygens, so that's why I wrote 2 of them. And then looking up oxygen on the periodic table tells me that oxygen always has a -2 charge because it's in group 16. And so each one of these oxygens has a -2. So if I total that up, that means this side, that what I boxed in green, the 2 oxygens in that formula, total, they have a charge of 4 minus, because each one is 2 minus. So then that means that over here on the side for the 10, it has to be 4 plus, okay, to balance it out. But there's only one 10, because there's no, if I look right here, there's no subscript. So that means there's one 10. So if there's only one 10, that means that entire 10, the whole thing has to have the +4 charge. So that means that it's this one, okay? Which means that if I wanted to write the name, so I'd write 10, and then since it's the +4, I need to use the Roman numeral for 4, which if you don't know your Roman numerals, make sure you write those in your notes, because it's IV, because you always put once you get past 3, that's where the V for the 5 comes in. So you put the 1 in front because it's like you're subtracting 1 from 5. So 10 and then 4. And then what's the second part of the name going to be?
Oxide?
Oxide, because it's oxygen, but remember we always change that second one to IDE. So this is 10,4 oxide. Now, what would 10,2 oxide look like? Well, 10,2 oxide, it would be what we don't get a lot of in Texas. It would be snow. Okay. So 10,2 oxide, its formula would look like this, because if I did the math thing again, I only have 1 oxygen in this one. And so it's 2 minus from the periodic table. So that means, total there's 2 minus, which means that the plus side would have to be a 2 plus. And since there's only 1 10, it's 2 plus. So be careful, because on one like this, a lot of people on something like this, they go, oh, it's a 1, because there's only 1 of each, because you fall into that like trap of thinking that the subscripts are telling you anything about the charges. The subscripts do not tell me anything about the charge. The subscripts just tell me how many atoms of that element are in the compound. Okay, the charges all come from the periodic table and knowing how many electrons that they're going to gain or lose based on what group they're in, how many valence electrons, I mean. So that 10,2 oxide would look like this. So then this would be 10,2 oxide. Okay. Let's do one more. I'm gonna give y'all one, and I'm gonna give you guys a couple minutes to see if y'all can do it before we go through the answer. Okay. I'm gonna give you guys, let's see. Trying to think of a good one. Okay, there we go. So Cu2S. So first off, what are my elements in this compound? What are the names of these elements? Let's start there, and then I'll let you guys see if you can figure it out. Anybody know what Cu is? You can look it up if you need to. You can pull up a periodic table. And look up. Yeah, so Cu is copper, which copper is a metal, and it is a transition metal. So that should be my like A, that tells me it's ionic, and B, the fact that it's copper, that's a transition metal, that should be telling me, oh, I'm going to have a Roman numeral in this name. And then what's the name of the element S?
Sulfur.
sulfur. So those are my two elements. I got a metal and a non-metal. So next thing I would need to do I would need to look up the charge on my non-metal. So I'm going to give you guys maybe a minute, 2 minutes. I want you guys to see if you can look up your non-metal and see if you can start working through the process like we did on these two, where I kind of look up the charge and I use that charge on the non-metal to work backwards to figure out the charge on the metal, so I know which Roman numeral to use for the name. So I'm gonna give y'all a couple minutes and then we'll check in. So you be working this on your own. You can do it on paper or however you want to do it. And then after a couple minutes, I'm gonna come back and check on you guys. Okay. So I'm gonna kind of go mute for just a minute. All right, I'm gonna check back in. So have we figured out what sulfur's charge is? Because that's the first thing, is we need to look up sulfur on the periodic table and find out what group it is and what charge it's gonna have. So anybody know what group sulfur is in?
It's a 2, like -2.
Yeah, so sulfur is going to be -2. It's in the same group as oxygen. It's in group 16. And remember, I told you anything in that group is -2. So that's one of those things, like actually taking the time to memorize which groups have what charges. That saves you a lot of time, because then you can just quickly look at the group and go, oh, group 16, that's -2. Or, oh, group 2, that's +2. Oh, group 1, that's +1. Group 15, that's -3. So memorizing those actually saves you a lot of time on things like this. So I only have one sulfur because right behind it there is no subscript. And guys just told me that it's going to be a -2. Since there's only one of it, that means that the total charge is -2. So then if I come over here, that means the total metal charge has to be +2. Okay. So here's the thing though. How many coppers are in this formula up here?
2.
There's 2, right? So this is a little different than the other ones. There's a subscript on the metal now. So that means there are 2 coppers here sharing that +2 charge. So if they're sharing the +2, how much is each one of them going to be?
+1.
Yep, they're each going to be 1. So they're each just a plus. You can put a 1, but if it's a 1, you don't need to write the number. You can just write the plus or the minus sign. So each one of them is a +1. So then when I go to do the name, what Roman numeral am I going to use?
2.
You sure? What charge does each of these coppers have?
1.
1. So that means it's copper 1. Okay, so remember the Roman numeral tells me the charge on the individual metal. So since the total was 2, but because there were 2 copper atoms in this formula, I had to divide that between them evenly. So each one is only a +1. That means my Roman numeral is a 1. Okay, because remember the Roman numeral tells me the charge on my metal ion. So copper 1, and then what would the second part of it be? Yeah. Should be see if I can fit it on there. Sulfide. Okay. So this would be copper 1 sulfide. So that's why I wanted to show you this one, because I wanted you to be careful, because if there's a if there's a subscript on your metal, you know, that means you have more than one of them, and this positive charge, you have to divide it between them. Okay. And so since there was +2, and there were 2 coppers, each one of them was a +1, which is why we used this Roman numeral 1 in the name. So a lot of people will get confused. They will look at this subscript and they will say, oh, there's a 2 on the copper. That means that it's copper. They'll say, oh, it's copper 2 sulfide because of the 2 that's right behind the copper. But remember, the subscript just tells me how many atoms of that element there are. It does not tell me anything about the charge. So keep that in mind when you are doing practice later on, okay? And our bell's about to ring, so I will see you guys on Wednesday. But if you need extra practice, remember those videos are on the page if you need to do them. Somebody about to ask
Mrs.
something.
Thomas?